Good morning, good afternoon, good evening, wherever you are. I'm delighted to be able to deliver this Securiton webinar on lithium-ion batteries and the detection solutions that we offer. Just a small plea before we start: if you can switch off your microphones and cameras, it keeps the bandwidth low so that hopefully I can do this presentation without interruption. You'll be able to see everything that you need to see. Very briefly, the agenda for today: I'll talk about battery anomalies, failures and codes, move into the BESS market, the battery energy storage market. We'll talk about our gas flammable and VOC sensors in a bit of detail, and finally we'll have a summary and some time for Q&A. Just a little bit about myself before we go too far. I've been in the fire industry a long time, but still very young. I've got a lot of experience in aspirating smoke detection, but I did have a sideline focused on lithium-ion batteries and related failure and technologies that could be used to assist in keeping whatever operation, whether it was a battery storage container, a UPS in a data center, technologies that could provide detection and keep business continuing. And I've got a very broad experience of all sorts of detection technologies and experience across the whole of EMEA. So hopefully I'll be able to bring some of that to today's presentation. We're going to start with battery anomalies. And as I do that, what I also want to say is that some of the technology that I'll talk about today is not Securiton manufactured. What we are very good at is selecting the right partners that really work for us, who've got technology that we can bolt on and use as part of our portfolio. So in partnership with Sensing, we are presenting to you today the Prevent Iron solution, and hopefully you'll be suitably impressed. It's the right solution. We are the right partners for battery protection, detection. They're with us very much so today, and they're going to be with us, these lithium-ion batteries, for a long time to come. And it's about preventing failure. So you can see here just a quick snapshot of a picture within a battery container. Sorry, my slides are presenting themselves. You can see here we've got a smoke detector, but we also have towards the top left there, if that's visible, a Prevent Iron sensor. And it's about detecting early failure, but also fairly late failure, because it's still important that detection occurs at all sorts of stages within the processes that these batteries are installed, and try and get some extinguishing to dampen down any burgeoning fire and maybe stop propagation to other containers or other parts of a building. It's just absolutely vital, because whatever we do, lithium-ion batteries, generally speaking, they're self-sustaining in terms of fire, and the propagation is pretty much unpreventable. So we need to make sure that we've detected not just early, but all the way through a process, so that we can actually stop major disaster. So failures come in all sorts of guises. Generally speaking, there are 4 failure modes for a lithium-ion battery. Quickly running from left to right, we have thermal failure, and that's obviously temperature, when the temperature either within, I'm going to use an energy storage container for most of my presentation as an example. So temperature is an issue either internally within the batteries or within the container itself, or something that's happened outside. Environmental failure, so that could be water somehow getting into an energy storage container. Power can often be an issue. These things obviously provide, but also draw an enormous amount of power. There can be failure within the power sources. And then finally, and perhaps unfortunately the most spectacular, mechanical failure. If any of you have seen perhaps videos or clips of batteries being mechanically damaged, either inadvertently or on purpose, you'll very quickly see a fairly significant reaction from that battery, and quite often that's just a very small battery that has had its failure. For very large systems, the results are really catastrophic. So failure is, it has multiple routes, but what we can do is use our sensor platform to provide really good detection to help us in this task. I'm going to talk a little bit about failures and codes for a moment. And I've talked a few times about large battery fires. That was a picture very briefly of a quite significant one. You could see that it was a large energy storage fire, and the news of energy storage battery fires will always be with us. This is one from not too long ago at a fire at a lithium battery storage facility in San Diego. And once those fires begin, there are not too many ways to stop it. So I'm going to stress it again, that if we can provide some early detection and then provide the mitigation, that is key. We've got to provide some form of suppression, extinguishing to dampen down that fire, stop it spreading, let the batteries effectively burn themselves out, because even cooling them to a significant degree doesn't necessarily stop further propagation. I take a little bit of an aside here, and it's something I only thought about or remembered this morning. But in the United States, and I do end up referencing a fair amount of stuff towards the United States, as they seem to have perhaps got most advanced in terms of safety and rules and regulations around lithium-ion batteries. In the US, there is an organization called the Energy Power Research Institute, and I put their website link on this slide. They've got a lot of useful information, and that they gather it globally on incidents, which is the kind word for battery failures, and they study in great detail what went wrong if the information is made available publicly. And it really is a very useful source for independent information on battery failure. Yeah, I recommend going to that website and having a look at the information that's available. It is very useful and very independent. As I said, the United States is really seems to be the focal point for rules, regulations, and battery safety information. The well-known NFPA group, they actually produce a document called NFPA 855, which many of you will be aware of, and it is the generally accepted global industry standard for the installation of stationary energy storage systems. And what we're now able to do with this partnership with infrasensing at Securiton is we can turn the various aspects of that code into really serious and fantastic detection solutions that can enable protection of not just energy storage, but UPSs within perhaps data center environments and indeed anywhere else. So let's have a look at lithium-ion storage and the codes that apply. So I make no apology for referencing the US a lot, but that's where a lot of this work has been done. So if I think about the various applications that lithium-ion batteries are used, obviously I've talked about BESS, battery energy storage, quite a lot, but there is an awful lot of lithium-ion batteries within IT environments, data centers, and also within telecom environments. And you can see listed there the various NFPA codes that apply. There will be other further national codes that may also be applied, and I obviously recognize that, and they should be taken into consideration. But it would be fair to say that compliance with NFPA or adherence to NFPA will mean that you are not too far away from national compliance, if not possibly over exceeding it. I know, for example, that there is, and I'm not sure if it has yet been finally published. Possibly it either has or has been, is very close, but there is an ISO standard certainly introduced this year called 3941 that will introduce a new classification of fires solely around lithium-ion batteries. And that's another document that is worth getting hold of so that we can mitigate against the dangers and problems of lithium-ion batteries and the classification Class L. Moving on to the BESS market, I really want to focus on the technology that we have now in this partnership with infrasensing. We actually have a platform that connects two different types of sensors, and I'm going to talk about those both in a second. If I think about the BESS market and battery energy storage, whether it's in a container form or whether it's in a rack in a data center, in my market, which is primarily the UK and Ireland, we have two approaches that we talk about. One is in front of the meter, and the second is what we call behind the meter. And essentially, in front of the meter is the container type systems. There's containers that we saw earlier that sadly some have had some issues and quite significant fires. And then behind the meter, really, we're talking about rack-based UPS systems. I should also say that behind the meter is often used for those who actually have energy storage at home. I know that in my own house, I have some solar panels and a small battery. That battery would be classified as being behind the meter. And it doesn't really matter whether it's in front or behind the meter. We're presented with the same dangers. We're presented with the same detection challenges. And it's true to say that thermal runaway, which is the process which is a catastrophic self-heating reaction within a battery, and at the same time it will cause some extremely dense and intense flames. The same problem, thermal runaway, can occur whether we're talking about in front or behind the meter. Batteries will, if we talked about the means of failure at the start, if there is a failure, batteries will go into thermal runaway and flammable gas can be released, and there's very much that can be done at that point to prevent total total annihilation, catastrophic consequences. Thermal detection, particularly if it's combined with some smoke detection. Here on this slide, you can see a smoke detector, but equally, it could be a Securiton aspirating smoke detection system that is offering protection in this environment. That will at least alert us to the potential problems. So let's say, and batteries, which we haven't discussed the chemical nature of them, there are a variety of types of chemical makeup of different batteries, whether they're LFP or NCM, and the chemical component parts of those, it's a variety of different gases that potentially leak if there is thermal runaway, whether it's CO, methane, hydrogen. They're different proportions depending on the battery manufacturer. But with the RS gas flammable detection, we're able to provide detection of that thermal runaway, whether it's emitting hydrogen, methane, ethylene. We can detect it using this R-gas flammable sensor. NFPA, which I mentioned a few times, it actually mandates that we detect gas triggered at 25% LFL, and that device must be integrated into the fire panel, and ventilating must be activated. So if NFPA is a requirement, wherever you're operating, we must include flammable gas detection. And the beauties, and they are multiple, in the Securiton R-gas flammable detector, is that it's calibration free over its lifespan. It doesn't require hydrogen field calibration. It's got a minimum 10 years lifespan. It can detect, operate from 0 to 100% LEL. It's got an extremely fast response time. We'll see in a second how we use the programmable relays. It can operate from -40 to +50, and it's also listed to UL 2075 and has a CSF FM listing, which are very important. If you're not aware of how important those are, let me or one of my colleagues know, and we'll direct you to the right documents. It's also really important, I think. Cost is always an issue, and I'm delighted that what we're able to offer is a very reasonable cost, capital cost piece of equipment. The R-gas flammable sensor is engineered with very reasonable cost of goods, and its raw cost is a very, very good price. But there are, additional massive advantages. Lots of other gas sensors require regular calibration. They require calibration per year. They require replacement of sensor cells. And I've listed here just some of the advantages. Yes, we've got to do a yearly bump test. That will be required for every single sensor on the planet. But what we don't have to do is replace cells every however long. It's got a 10-year calibration, and that will save an enormous amount of cost. It also, we're not having to do calibrations every year, and again, it's a cost saving. I think far too often people are just thinking about upfront capital costs and not taking any cognizance of life cycle costs. So total cost of ownership using the Securiton infrasensing R-gas flammable detector is really, really key. You can see here, this is just an example of a layout of, let's say, an energy storage container, or it could be a UPS in a data center. We've got our gas flammable that's probably positioned, and each design may be different, but it's positioned near the ventilation system from this area. We'll connect it to the battery management system via Modbus. We'll also use the relays that I mentioned earlier to connect both to the vent control and also to the fire panel. So we've got some warning, we've got some control, and that will enable further actions to be taken. We're not just letting it burn, as some people discuss and suggest in these environments. We're providing a detection system. We can then decide what further action is going to be necessary. So up to this point, that is taking care of what I would call my thermal runaway problem. This is quite a detailed slide, which I won't labor now for reasons of time, but what we're able to do with the our gas flammable detection is provide pretty much every solution to every question and problem that you'd ask within a typical BESS application. Other competing technologies can't answer all of the questions with a single product. It may be that they have to duplicate using at least 2 different technologies, and even then perhaps not reach the high standards that we would make and reach with our gas flammable device. We can provide a lot more information there. Again, if you just reach out to either myself or any of my colleagues, we can help you with that. It's not just the flammable gas that's the problem. What you're probably aware of is that before flammable gas appears, we've got what is termed off gas. There is a venting phase where off gas, and we'll look in a bit more detail in a second, where you get VOC gases, volatile organic compounds. There are some examples here on screen. Chemically, they are known as things like, I'll give you one example, DEC, which is diethyl carbonate, DMC, actually I'm going to give you 2 examples, dimethyl carbonate. They are electrolyte solvent vapors that are given off when a battery is first starting to fail. Now, this is pre-thermal runaway. I don't think there is any consensus anywhere about what the time lag is between VOC off-gas release and thermal runaway. It can vary between, I'm afraid, as little as a few seconds up to a maximum as several minutes, but we're not able to predict that, or at least not reliably. So we have the off-gas sensor. We call it a VOC sensor. It will detect the emission of those DMC or DEC gases. It will allow us, once we've detected those, to, for example, stop the battery charging to send a signal to the battery management system. Again, typical for all our sensors, we've got calibration free over an entire lifespan. We can actually provide a sensor that has a VOC index from 0 to 500. We can actually daisy chain up to 15 sensors on one system. I'm going to show you a little example in a second. Again, we have a lifespan of up to 10 years, and these sensors are UL 61010 recognized, which is a very important recognition. We've actually had a fair amount of what I call very independent testing of our sensors. This is a kind of preview example, if you like. I'm hoping that fairly soon we would be able to publish this data because it was very important testing. It was done some time ago, but I'd love to be able to publish this because it proved just how good our sensors were at detecting the off gas and then allowing us the time, however little or long it is, to actually do something about it. So I'm hoping that if not before the end of this year, early next year, we can promote that. So I talked about a daisy chain and being able to have up to 15 sensors. This is an example here. So we're going to assume this is some form of UPS room. Got actually a couple of daisy chain sensors here. We're connecting a number of sensors so we can detect that VOC, whatever it may be, and then send the signal to the battery management system, stop charging, stop power, stop the batteries. It may enable us to prevent thermal runaway. It may not. That's something that's so hard to predict, but it will enable us to do something about it rather than just ignore the problem and hope that it goes away. And here you can see everything put together on that same generic layout. I've got my VOC sensors directly within the battery racks, and I've also got my R-gas flammable unit so that I'm detecting that flammable gas and providing further control. The adoption of our solutions is really starting to take pace, and I'm just giving you one example here that the very well-known digital realty company are now mandating the use of VOC detection within their facilities globally. And what that's giving us really is, the opportunity to send the message out that there are lots of serious players who are starting to mandate use of this technology, both the VOC sensors for off-gas detection and the R-gas flammable detection sensors for prevention, detection of thermal runaway. I'm getting, thankfully, for you guys towards the end of my presentation, but I just want to run through a few things. We've got a whole design team or teams at Securiton who can help you with the design of these sensors, the systems, and we actually have quite a interesting BOM configurator that we use. If you have any battery risks that you need designing, make sure that you contact us and we will help you. I'm going to quickly do a summary and then we can have some Q&A. Just kind of wrapping up here, we've got, and this is happening everywhere. We got lithium-ion batteries are everywhere. There are risks. We need to make sure that we take them seriously. Adoption is going to continue at a great pace of these lithium-ion batteries, but to help everybody, we need to keep them safe. So in this rack example here, I'm showing again the slide with a smoke detector in it. I also have my VOC sensor. Equally, as I mentioned earlier, it might be that I'm using, perhaps in either a container or a room, I'm using very sensitive Securiton aspirating smoke detection. Fire is the most extreme form of thermal abuse. So if I am sensible about things, I'm going to have my R-gas flammable sensor within this space. I'm going to be able to pick up the smoke as well with my smoke detection. But what I also need to make sure I do is suppress that fire. Now, Securiton itself doesn't manufacture any suppression, but we have contacts with and can introduce you to suppression experts if you're not connected to them. Suppression is also key and is part of the solution in these environments. I've said it several times, but fire is the most extreme form of thermal abuse, and really detecting it requires novel approaches. Whether we're using the Securiton aspirating smoke detection in combination with the VOC sensor, plus the thermal flammable sensor, we've got to include some suppression of some kind as well. That is a plea that all of these elements are included in the detection and suppression philosophy for these environments. We have the capability to provide all of the detection. I'm going to stop talking and take questions in a second, but before I do that, what I really want to urge you to do is to sign up and connect to our social media channels. We are very active on all of them, whether that's LinkedIn, Instagram, or TikTok. Contact your regional guy or the guys in Securiton HQ in Switzerland. Make sure you're connected to us. As I say, we're very active. Please follow us. I think, Zach, I've got a few minutes left to take some questions, if there are any.
Yeah, the first question, Justin, is for the flammable gas sensor, you said there are 10 different types of gases.
Yeah, so I mean, I think it's up to 10, and I think I referenced 3 of them. I think I probably said ethane, hydrogen, and maybe methane, but actually there's quite a long list that includes gases like butane, isobutane, octane, propane. If somebody wants the full list, it's within our marketing collateral, or we can provide it. But it isn't just what I'd term the normal gases that people are looking for, like hydrogen. We do have the ability to detect up to 10 different gases that may be emitted.
The next question is, you offer free design service, you said, is that correct?
Yeah, it makes me laugh because I know that it's not something that many people offer, and so I always have to repeat it. It is a free design service. We operate it globally. We try to do everything in good time as well, but yeah, if we want to help our customers, we want to help everybody, we want to design and offer a service for our customers. So yes, it is true. Please contact us.
And the next question is, how is maintenance VOC sensors performed?
Good question. So we use or suggest you use either a DMC or DEC small bottle that can be used for bump testing. It's, as far as I'm aware, they're not necessarily easy to acquire, but most countries will have a supplier of little test bottles containing DC gas. If they're not available, then you can use ethanol or acetone as alternatives. And all we do is place either the little bottle or sometimes a cloth covered with DMC or DEC across the sensor and just wait 10 seconds and the sensor will operate. Again, we have information that we can share and help you to provide that service.
The next question is, how is your VOC sensor calibration free?
Yeah, it's another really good question. The answer is a bit technical, and that's not me deflecting it. I'm going to give you a short version to it, but if you want further information, we can of course provide it. But we use a kind of metal oxide sensing semiconductor sensing technology, is shortened to MOX. And essentially the sensor achieves automatic baseline calibration through a built-in algorithm that's continuously monitoring and adapting to the surrounding environment. And it's often referred to as dynamic baseline correction or automatic baseline calibration, which is shortened to ABC. Now, that was the short version. As I say, I'm happy to provide a much longer explanation and details, but the shorter version is the sensor is calibration free, and it's a massive advantage in cost saving potentially.
How does VOC detection work?
Oh, well, it's a complicated one again. I mentioned it a couple of times, I think, that we're measuring the VOC, the volatile organic compound index, between a range of 0 to 500, and essentially a value of 100 is essentially saying your environment is clean, and that anything below 100 is, I suppose, the air getting cleaner, and anything above 400 indicates that there's a really high level of VOC and potentially a problem.
And the next question is, can I connect these sensors to the BMS system?
Oh God, absolutely yes. You know, and that would be a strong recommendation from us, that they are connected into the the battery management system or the building management system. If it's let's say a UPS within a data center.
Good. And the last question, Justin, is, can we integrate VOC detection directly with an ASD?
No. Again, it's the short answer. The off-gas detection, it wouldn't work, because the VOCs, they're present as background gas, and the dilution would make it undetectable, or at least undetectable to be reliable. There is a possibility, we're looking at it in combination with the flammable sensor, but I would counsel strongly against incorporating VOC sensing into any ASD.
Thank you, Justin. So due to the time constraints, questions which remain unanswered will be answered by email during the next few days. So Justin, thank you very much for the presentation, and thank you everybody for attending our webinar, and we look forward to seeing you again for our next webinar. And until that time, bye-bye. Have a nice day.